Hello, as you can see in this question, it is asked that there are two spheres, as you can see here. A metal sphere with radius R1, this one, has a total electric charge of magnitude Q. So it has charge of Q. An uncharged metal sphere with radius R2. This is uncharged, that means charge is 0. Okay, with radius R2. Okay, as you can see, R1, this one is bigger than this one. That is what they have told here. R1 is greater than R2, is then connected by a wire to the first sphere. Now this one is connected by a wire to the first sphere. Okay. Now when it is connected, obviously there is, at the beginning, when it is not connected, there was difference in the potential, electric potential. Electric potential, which is denoted by V, volt. And here the voltage is 0. The formula of electric potential is V is minus K Q by R. Okay, R is the distance between the charges. Okay. Now, since this guy is having charge of Q and R is equal to radius is equal to R1. Okay, we don't have to be concerned about radius. Okay, since it is having some charge, that means it will be having some higher potential. That is for sure, because anything has charge has potential, electric potential. Okay, so we are sure that it has potential. Now when this sphere, which is having charge is equal to 0, that means if we put Q here is equal to 0, we'll get potential is equal to 0. That means the electric potential here in this case is 0. Now when it is connected by wire, what will happen? Charge will flow from here to here in order to make sure that they have equal potential. Charge will keep on flowing from higher potential to lower potential. Okay. Now the question is, when they is then connected by wire to the first sphere, as we can see by this wire, as illustrated above, the separation of sphere is much greater than the radius of either of the spheres. This separation is much greater. Okay. When the equilibrium is reached, so this is very important. When the equilibrium is reached, the spheres will have charges on the surface of the equal magnitude and the same sign. Charges on the surface of equal magnitude and same size. Since you can see the radius is bigger in this case and radius is smaller in this case, that means that is not true. Charges won't be similar. Charges on their surface will be equal to the magnitude, equal of magnitude and opposite sign. No, we are not sure about that. The equal electric fields at their surfaces. No, we are not sure about that. Equal capacitance, there is no question of capacitance here. Only possible answer is equal electric potential. Why the charge will flow from here to this sphere? In order to make sure that they have reached the equilibrium. How do they reach equilibrium? By making sure that this V1 is equal to this V2. Okay, that means this sphere will share some charge to this sphere, which is having no charge, so that they come in equilibrium by making sure they have equal electrical potential. So this is the correct answer. Thank you.